Welcome back. In the last video, we talked about the basic rules of Mahjong, how you can obtain a winning hand and what is a winning hand. To recap, a winning hand is a hand with four sets of three tiles and one set of two tiles. The sets of three tiles must be either a triplet or a sequence, and the set of two must be a pair. This is the most basic way you can win in Mahjong. And there are a lot of other ways, but this is the most straightforward, simple to understand way. Now, in this video, I'm going to cover two other core components of the Mahjong rules. The first one is called Pun, and the second one is called Con. So, Pun and Con. A pun is when you have a pair and someone else plays the exact same tile that you already have as a pair. In that case, you can just grab their tile and put it in your hand, and that forms a triplet, which in this case is called a pun. So, say I have a pair of eights. This is character 8. And if someone plays another character 8, I can just take that 8 and put it into my hand and take the triplets and put it aside. So as you can see here, I already have two puns. This is pun for bamboo 9 and pun for bamboo 6. This is important because it directly skips all of the waiting time. So if anyone plays a character 8 right now, I can just grab it immediately and it will be my turn to play a card. This is also useful because you basically get a new tile and you have the chance to get rid of one of your bad tiles. So it's a very interesting and strategic move. Sometimes it might not be the best case to perform this action, but sometimes you might want to do it. So like in this case, right, I have eights, but I don't have anything remotely close to 8. I only have 3, 4, 8, 8. So in this case, yeah, I might consider doing the pun, considering I already have two puns. And if you have an entire hand consisting of puns, then that's a type of win um, that is bigger than a basic win, right? So it's very strategic. But in terms of coding, uh, I spent like maybe 2 days or 3 days on this functionality. Before I go to the code, let me just explain the other core game feature called a con. A con is very similar to a pawn, except this time you have three tiles in your hand, so a triplet in your hand. And if someone plays the fourth tile, remember for each tile, there are only four. So if someone plays the last one, you can say con, which then puts all four together into a group. This is a little bit more complicated because this means that now you have a group of four. And the most straightforward way to think about it is if you consider this group of four a group of three. So just treat it as a normal group of three. And right after you get that group of four, you immediately draw another card or another tile from the center. And then you play another tile. This is so that you always have the same amount of tiles in your hand if you treat the con as a group of three. Cons are really important because one, they are very rare, and two, they can give you money, right? So every time you con, it's almost a guarantee that you will get some money out of it. If you get a basic con, uh, I'll talk about the different types of con in just like a minute, but if you get like a basic con, you immediately get like 1 point, pretty much. And if you get like a more advanced con, you can get 2 points from everyone, right? So you always get points from it. And the third benefit is if you ended up winning, each con you have doubles the amount you win. So it's like a really important part of this game that I will have to program. So there are three types of cons. The first type is if you already have a pawn right here. So as you can see, I already have a pawn of nines, right? Bamboo nine. If I draw another bamboo nine at this point, so say this one, which is the new one I just draw. If this one is a bamboo nine, I can just combine this one with this group, and that forms a con. It's straightforward. In that case, everyone gives you 1 point. And if I add this to this con, I need to draw one card and then play one card. Now, the second type is if someone else plays, so say I have 3 8s, right? These two are 8s, say this one is also 8. If someone else plays another 8, I can just con on them. So I can take their tile at any time if they play it and perform the con action. That's the second type. And in this case, only that person will have to give you 1 point. The third case is when you have all 4 tiles in your hand. So none of them are displayed, none of them are in a pawn. It's just a natural call in your hand. That case, everyone gives you 2 points. It's important to note that for pawns and cons, once you place them on your table, so if you decide to pawn, right, you have to show everyone, oh, I'm pawning this, or oh, this is my con. So once you put them on the table, you cannot manipulate them. So you can't say, oh, wait, I want this line back. No, you can't do that. This is a group that has to be included in your final winning hand. And you can't just change the group, right? Okay. I think that's pretty much it for the rules, these two mechanics. And right now I only have pawns set up. And if you get a pawn, you can choose to basically pawn. So if any of the AIs plays an 8 right now, right, I have the choice between choosing to pawn or choosing to not pawn. And I can do that by using P to pawn. So it will it will say press C to show, P to pawn, K to call, S to skip. So I'll just press the corresponding key and the action will just happen. And then I have to play another tile. The only reason why I think this is a little bit tricky is because it messes with the hand and also messes with the game turn. And it's, I don't know why, but my program um kind of runs really poorly, uh like in terms of organization, right? So I had to do a lot of reorganizing to get this working. And also remembering episode 1 where I talked about my tile object, how each tile object stores an image. Well, turns out that wasn't a very good idea. And now I just load all of the images. And whenever I want to draw a tile, I'll just look up the images in the already loaded dataset. So this way, it's not as slow, right? If you're constantly going back to your folders to search for images and extract them, then that's going to be much slower than if you just process them in your memory. Let's get to the uh pawn strategy. So what I did was in the game panel class right here, I added this update. This thing existed from day 1. I just didn't use it, but now it constantly checks while the game is running. It constantly checks if H key is pressed, P is pressed or S is pressed. Also, in the player status checker, every time I play a tile or anytime an AI plays a tile, it checks everyone's status and updates them. So let me show you how this works in the game class. So every time I call next, which is to advance to the next player, right? I have this new player status checker that checks the turn player and turn player's hand, get new tile. New tile is the tile they just draw. And turn player is the player that, is supposed to play, right? It's his turn. So I'm checking this player's hand against the new tile. It passed a player in, but in reality, I'm just using the player's hand. So I'm just using player's hand, which has 13 tiles usually, unless you have a con or something else, and then a new tile. So it uses the same class that checks for victory, and it checks if it's a con or if it's a pawn. And if it is, it goes to the player and then it sets a pawn status onto the player. This tells the program that the player can pawn, but he doesn't have to. So then the program is going to wait for the player, basically. Let me go to the game panel right here. All right here. So if player plays a tile, right? If mouse is pressed, right? The player is going to play a tile. And if you go in here, the player plays a tile. This is the logic in the player class. So whatever the player is going to do, it's defined here. And then if we go back, if we go back, you see there's this line that says game.process player played. This method is in the game class and it processes what happens after the player played. And this is the function that checks if the player has the pawn. So we have the turn player, which is the player who is supposed to play. And then for each player in the next three players, I am also checking if they have the status. So player, which is one of the players in the next three players, I'm checking that against this turn player get table get last. Remember, at this point, the player has played their tile. So I can only access the tile from their table and getting the last one because it's the one they just played. And I'm just double checking for all players in case anyone wants to jump in and get the pawn, right? So then player played, set winning status, and if the player doesn't have one of these statuses, it just does some logic for status checking. Where the logic really comes in is if the player chooses to press P, right? If the program stops and waits for the player has to respond with a P press, an S press, or an H press, or more presses that we'll add later. But right now, it's just these three. This one doesn't even work, so it's just these two. If P is pressed, then and then you also check if the player's status contains pawn, right? You don't want any P press to trigger it. You're going to process the pawn in the game class. And this is going to essentially add a pawn to the player's hand. And the way I did the add pawn is I create 3 new tiles with the given tile, and then I remove 2 from the player's hand. This is the only way you can add or you can pawn, is if you have 2 in your hand and there's a third one out there, and boom, you get the pawn. So this is the logic. Then after you get the pawn in the process pawn, you create a new game turn object, starting from this dot player, because player just pawn. So now you want to start with the player and then continue on, right? So the previous game turn wouldn't work. So I just created a new game turn object starting with this dot player. And then the turn player will be this dot player dot next, which is always going to be this dot player. This is the way my game turn works. As you can see, the constructor construct this object with a list of players and then the starting player. And it adds the starting player first. And in the next call, it will just remove the first one. So this is always going to be always going to be this dot player, which is just the player. This dot player, this dot player is not the same as player. Just to not be confused. This dot player is constant. It's always the active player, like the real life in-person player. And this player can be anyone, right? This player can be an AI. So I should change this to player, I think. But right now I'm just trying to get the interface to work for the player. So yeah. Then some variables for outputting. And I have this game state object, which I think from 2 lectures, or not lectures, sorry. Why did I say lectures? From 2 videos ago, I think this is called output data or round data. I just think game state is a better way to put it, because I just want to process all of the game related logic in the game class. So there shouldn't be any logic processing in the game panel class. So this is why we need an object for data transfer. I want to transfer all of the game data at one snapshot to the game panel class so that the game panel can display all of the relevant information. So here we see game state equals game state. This is a static function you can just call whenever, basically, and it will just provide you with the most updated game logic data. And did I go over the logic? I think so. Yeah. So then you just return the game state, and then yeah, just display whatever is there. This game state has a lot of objects and data in it. So it includes stuff like, for example, stuff like each player's table, and then player's tile, and then player's pawn. This is I guess, the most important one, because this line is responsible for generating these. And yeah, I also added some log, so it's better to, or easier to debug. So here it shows the player, oh, now it's your time to make a decision. Press C to chow, P to pawn, K to call, or S to skip. Chow just means if you're one tile away from winning, you can just get it from anyone. Let me rerun the program and show you guys how the pawn thing works. So I'm just going to play off the dots, because all the AIs will automatically play bamboos. And that gives me a better chance of getting a pawn. So I'm just going to play off the dots. So boom, boom. I'll keep the bamboo. I'll play this. I'll play that. And as you can see, it says proceed to show feature pawn. And this is because I have 2 4s, and this AI just played the 4. So now I can choose to pawn. And watch what happens here to this tile and these two. Okay, I'll press P now. Boom. It takes the 2 4s away and this one away, and it adds them there. And now it's my turn, and I have to play 1 tile. So now place 1 tile. So I'll play this one, and I get another one. That's very unlucky. Let's try to see if we can get this one. So let's keep going. Boom. I think we got it. Yeah, there it is. So if I press P, this one and these two will disappear. And then I'll just play another one. And then now it's AI1's turn, AI2's turn, and then 3, and so on. And the game continues. Adding con to this is much more, or it should be easy, I think, hopefully. And yeah, after that, I think I'll just have to work on getting the winning system right. So testing if the game actually detects all of the different ways you can win, including all of the hard ones and the special cases. And after that, it will be time to write the AI and train some code on it. I think I can get to the AI part in about 2 days or so. So yeah, this project is, or building the program part is almost done. So yeah. All right. Thank you for watching, and I'll see you in the next video.